completely unprepared. That's just, we just wing it. All right. I'm not winging this, though, because I know the answer for this one. I just looked at it. I didn't read it really carefully, but now I've read it. I know the answer. Probability that you're going to get ahead when you flip a coin, that probability is 1/2. Probability if you roll a die and get more than 4. 4 is not included in that deal. More than 4 means it's either 5 or a 6. That's 2 out of 6. So when you multiply those together, you get 1/6. So you do have the first one correct. Letter B. The one that causes fits for everybody. So you got person A and you got person B. Well, what day is this person born on? No. So if you say 1 out of 365, then what you're really saying is, I'm trying to guess the very specific day they're born on. Do I even care what day they're born on? It really makes no difference. This person actually has 365 days. Whatever day he's born on can't be wrong. Does that make sense? He cannot be wrong. It's not like he goes like this, my birthday is January 5th. Liar! I mean, whatever he says, that's just what we're going to go with. It cannot be the wrong day. So that day cannot be wrong. Now, what's the probability that this person doesn't match this day? Well, in essence, he's giving me the target to shoot for. This guy is giving me the target to shoot for. If he says his birthday is July 8th, then the probability that this person was born on July 8th becomes 1 in 365. So the probability he's not born on July 8th is 364 out of 365. And would it make a difference whether it was July 8th or August 2nd? No. Probability he's born on August 2nd, well, that would be 1 out of 365. Probably he's not born on August 2nd, 364 out of 365. It doesn't matter what day you say. I mean, like say he's got the luckiest birthday in the history of the world. Okay? What are the chances this guy's born on December 25th? Well, it doesn't change. Any one day of the year has the same probability. It's 1 in 365. Okay? Now, if I say, what's the probability that two people are randomly selected and they have birthdays that are January 5th? Now that's 1 out of 365 and 1 out of 365. Why? Because this guy could have a birthday that's not January 5th and be wrong. But that's not what the problem says. Okay? So your answer is 364 out of 365. So I think you got that one right too.
You did.
You guys are superstars. Now, integrity code consists of 6 random letters. How many possible codes can be created? Well, there are 26 letters in the alphabet. If it said 6 different random letters, that would be what? That would be 26P6. Because the code makes a difference whether how you type it in. Right? I mean, if you have a gift card code, you know how gift cards work? You type the code in like iTunes. Do you have to put them in the correct order, or you just have to get the numbers down there somewhere? That is correct order matters, so that would be a permutation. But because we're not saying different codes, we're saying just 6 random letters, that would be 26 raised to the 6. So you got that one right. Now to the urns. The problem that people wake up in the middle of the night on test day thinking about. For those of you that have never seen the class before, Sarah will let you know there's urns on there. And you're the one who asked the sub to do the urn?
Yes.
Were they able to do it?
Yeah.
Good.
Like after he read the question like a million times.
Good.
Yeah, he had to walk himself through it too.
Yeah.
Right. You all have to walk yourselves through them. They're always hard. You have 6 red ones and 5 green ones. You have 7 red ones and 8 green ones. Now what I say we're going to do is we're going to take one out of this group, and when we take it out, we're going to leave them with an equal number of red and green. So at that point, you have to figure it's got to be a red one that you take out. If it's not a red one, you're not going to have an equal number. Okay? And so If you take out a red one, you'll have 5 reds, 5 greens. So the probability you take out a red, 6 out of 11. If you have to do it here and take one out, you're going to have to take out a green one. So that's 8 out of 15, which if you reduce, divide by 3, this is 2 over 5. This is 16 over 55. And you got that one right as well. Probability of selecting a male or B. How many males are there? How many males are there? I think 23.
I was looking at the wrong column.
Now, if it's not a male, if it's not one of these, who else could it possibly be? It could be somebody who chose B. So we're looking at those 23, and in addition to those 23, we're also looking at the other 15. So how many people do we have altogether? 38 out of 50. If you reduce that, you'd get 19 over 25. And you got that one right as well. Okay. If 3 different people are randomly selected, what's probably they all selected A? I think everybody understands that there are 26 people who selected A. I think everybody gets that. If you just do 26 over 50 raised to the third, that would be a very fine answer. Except for that allows the same person to be selected 3 times in a row. If you're at a banquet and the same person wins all 3 cash prizes, that's going to suck. Huh? They won't make it home. The winner of the $10,000 grand prize is Jack. Now it's time for the secondary prizes. The $5,000 prize. Hey, Jack, come on back up. Now for the $2,000 prize. Holy crap, Jack, come on back up here again. No, you can't let Jack win all 3 times. So once Jack is taken out, if there was 50 people all together and Jack already won, how many people can win now? Only 49. So you have to cut that down by 1 each time you do it, right? The second place guy goes up. How many people are left over? Well, now you only got 48 people to choose from. So this assumes you can select the same person twice. This says they have to be different people. So it is 26 out of 50 times 25 out of 49 times 24 out of 48. And when you do this, this is 1, this is 2, this is 1, this is 2. This is 1, this is 13. Looks like your answer is 13 out of 98. Or you could just type that into your calculator and press enter. Hit math fraction, it'll tell you 13 out of 98. Okay. Find the probability of female and A. Female and A. So with that one, you have to be looking for a female and somebody who chose A. So how many females are there that chose A? There's only 12. So there's 12. 12 out of 50. Which if you reduce that is 6 out of 25. So you got that one right. You got the other one right. You've gotten all 3 of those right. And you're now down to B. The line. What does the line mean? It means -5 for some people. But for you all, it means you started from the bottom, now you're here. How many people chose B? How many people chose B? There are 24 people who chose B. So that goes on the bottom. How many of them are male? 9 are male. 9 out of 24, which if you reduce is 3 over 8. I played this 4 times. The only class who got all 8 questions correct is yourselves. Give yourself a hand.